Okay. Looking at this graph, what would you say are the zeros? Antoinette. Notice that these are every 5. How many zeros are you seeing there? What? How many zeros are there? Right? Here, here, and here. What are they? Now you got it. Okay. Okay. If you want. Okay. If those are the zeros, what are the linear factors? Ryan? No. Remember, how do you make a linear factor? Not x plus. Chloe. Listen to Chloe. Okay, so first go around here, right? X minus negative 10, X minus 0, and X minus 15. Okay, but we wouldn't write it like that, would we? X minus negative 10 is X plus 10. Okay, X minus 0 is X. And X minus 15 is okay. Okay, so those are the linear factors. The one that we always make a mistake on is when you have a 0 of 0, that X is the factor, right? That's the one that we always mess up. Now, looking at the shape of the graph, what would you say is the degree? Meaning the highest power. Which polynomial has 2 turning points? What do you call it? Cubic, right? A cubic polynomial either does one of these or it does one of these, right? What was it that determined whether or not it was like this or the opposite? What was positive or negative? What you would call the leading coefficient, the A. If it's going from positive numbers to negative numbers, the A must have been negative. That's why we've got that. So we would say this is a cubic polynomial, and that's why it has the shape of the graph. Okay, there's some other things that we could see on here, some of which are in the SOL and relatively important. We struggle with them in pre-cal, even now, and in calculus. But they're not really very well discussed in our textbook. But some of them I'm just going to mention anyways. One of them is these points right here. Notice that this point right here, it's not the minimum point on the graph. Not like with a parabola, you know, the vertex was definitely the minimum. That's not the minimum point because it goes lower over here. But it's a relative minimum. It's lower than the points that are just around it. If I go a little bit to the left or a little bit to the right, the graph goes up. That's what you call a relative minimum. Same thing here. This is not an absolute maximum. It's a relative maximum because it's the highest point in its vicinity, right? It's a little bit less to the left, a little bit less to the right. We don't have a way to find those algebraically until we get to calculus, right? We do have a way we could do it in the calculator. If we knew the function, the calculator has that function, but it's not really part of what we do here. If you go second trace and you see the minimum and maximum, you can find those points with the calculator. But you can't really solve for them like we like to do in an algebra class, not until you get to calculus. Now, another thing that we talk about is whether a function is increasing or decreasing. It's decreasing when it's going down from left to right. So this piece of it is decreasing, this piece is increasing, and that piece is decreasing. Right. Now, when you name the intervals of increasing and decreasing, you mean the x values, right? You don't mention the y's. I mean, we might say this is 10 and this is -5, but we don't care about the y values. We care about the x values, right? If we wanted to say the interval during where it's increasing, we would say it's increasing from -5 to +10. because it's between those two x values. Normally, the way you would write it, like this, you'd say -5, comma, 10. That's not a point. That's an interval of x. Now, if I wanted to say the interval where this thing is decreasing, then it's decreasing. We assume this goes on forever. So it's decreasing from -infinity until -5. And then how do you think we would say this interval to the right of that line that's increasing also, decreasing also? The left bound is 10. And what do you think the right of that interval is, since this goes on forever? Infinity. So increasing and decreasing is something that we're supposed to talk about.